Hello, welcome back to the video lecture series for Introduction to the Art of Programming Using Scala. We've looked at arrays and lists, and we've talked about the basic methods that are available on them. At this point, I want to kind of take a little detour and actually run through an example. So I want us to fill an array with some data and then play with it a little bit. Now, there are lots of ways that this can be done, and in fact, we're going to learn about, in some ways, what are better ways, perhaps, later on in this chapter. However, to tie things together, I want to fill our array using a recursive function at this point. And now the question is, okay, well, what data should we put inside of here? And one of the wonderful things about the current version of the internet, and also one of the reasons why everyone should learn how to program, is because there is so much data that is available out there. I will try to pull in a number of different data sets over time. For this example, I'm going to pull in weather data. And so here is a website that has historical weather data, both daily and monthly information for different sites. And so if you click on the web interface here, you can select the state. I am actually going to select my current location. And then we can scroll down. And I happen to be in San Antonio. And so when I click on that, it pulls up this, and I could get monthly data. I actually want to play with daily data. Part of the reason is because there winds up being lots and lots of it. Number of days, non-missing data for these years. You notice that this lists 1946 to 2011. So we have a pretty long baseline for stuff here. And what I'm going to do, so you can use this and you can have them plot information for you, but I want us to get data in a format where we can read it in. So if you scroll down a little bit, there's the write a comma-separated file to a download area. And so I'm going to save the precipitation. San Antonio doesn't have snow. Low temperature, average temperature, and maximum temperature. And I am going to, go the entire range that they have. It will output it in this file. And so if I click submit, we wait just a little bit. And now, so your download file has 9 columns and 2 header records plus 23,863 data records in approximately blah, blah, blah bytes. And I can save it just by clicking here. And so it goes and it saves it down there. This note will wind up being significant to us. Note, missing data values are indicated by a period. So we'll have to see. There probably are some missing, a few days of missing data in here. So now that we have that, it's saved in my default location for things. So I'm going to move apparently I have 2 of these. I've done this in the past. This file was the 336. Okay. So I'm going to move that file from downloads into my current directory, and we can look at it here. We can use less to go through the file. Now, you'll note some things here. So it starts with a header, one line here just showing you where it came from, another line showing you what each of these fields are, the day of the year, the month, tag for the state ID, what year it is, the precipitation in inches, the low, the high, or actually, wait, it's the average, the high, and the low. Okay, so that's the order of the different data. And if we jump down here to the end, yeah, it goes up to 2011. Now, I want to know how long this file is. So if I do a WC on it, I can get a word count. This file is 23,865 lines. This is how many words there are, and this is how many characters there are in it. I'm actually going to edit the file, and you'll see why in just a second. First off, I don't care about these top 2 lines, so I'm going to delete them. And now, if I save, this tells me how many lines there are. There are 23,863 lines in this file right now. And so I am actually going to paste that number here at the top. Because the way I'm going to write the code, the first thing we're going to read is how many lines of stuff we should read. And then we will go through, we'll make an array that's that big. One of the things about using an array for this is when you make an array, you have to say how big it is. So I will be able to specify that the array is that large, and then we'll go through and read things. Now, that's where stuff might get a little bit more interesting. Let's go ahead and let's start a file. I'll call it temps.scala. We'll pull this up over here. It might be helpful to us. So let's make a variable for how many lines there are and have it set to be readInt. So that will read this right here. And then each one of these is a whole line. How about we make data equal to, I don't know, data equals a new array of doubles. Almost everything there is doubles. We'll talk about that in just a second. Or actually, how about we, how to do this in parts. Okay. Okay. Now, doing a top-down design here where so I've made an array, called it lines, and it's an array of string because when we read this in, well, it's going to be read with a read line. It's going to give us back a string, and we have to figure out what to do with that. We'll have to break that up in a second, but first we can read it all in and make one array that has all of the lines as strings. I am kind of assuming here that I have a function called readAllLines. I passed it 0 and lines. The 0 here is for what index I am reading into. And so when I declare this function, index will be an int, and lines is an array of string. This function has no return value. Because the array is mutable, it is going to store values in the array as opposed to doing some calculation and giving us back the value. We're actually going to alter the array here. Now, we're writing a recursive function. You have to have a base case. When should we stop? Well, if this index gets up to the number of elements in lines, we would have problems if we kept reading because we've run out of space. So I'm only going to keep doing stuff if index is less than lines.length. If it's not, that means the whole array is full and we are done. If it is, then lines sub index equals read line, and I call read all lines on index +1 and lines. Here we have an example of I am not counting down, I'm counting up. All of our previous examples of recursion where we did things multiple times, we were doing a -1. In this case, I know when I'm going to stop. I'm going to stop when I get up to the number of elements in the array. So I'm going to count up. Remember, I want to be moving towards my base case. If I start at 0 here, and my base case is when index gets big, well, then that's what I need to do. And just to show that we were able to read this, print line, how about lines dot last? I could try to print out all of the lines, but as you've seen, this is a rather large file. I'm hitting page down now, and I would be paging down for quite a while because it takes a while just for the years to get updated. So if we quit out of that and we run our temps, now here's the thing, if I just run this right now, it's going to want me to type in, so the way this works right now, let's run it. Nothing got printed. It's waiting for me to do something. Well, let's say I was going to type in 5 things. Okay. Whoop. Read all lines. There was an error on line 5. Got ahead of myself with the typing. Oh, I see. Missing L. Lowercase, right there. My first thought was capitalization error or something along those lines. Okay, so now cap has done it, and if I type in 5, A, B, C, D, E, it prints out the E at the end because that was the last thing. I want that whole data file though. Well, clearly I am not going to retype that data file. This is when the less than symbol comes in handy. So remember that less than makes it so that instead of reading the input from the keyboard, it's going to read the input from a file. And so if I run this, it goes through and first it reads the first line of the file, which was how many other lines there are, and then you will see that, and we can indeed tail our file to see that 31, 365, 12, and 2011 is our last line here. So we managed to read the whole line, and or the whole file, and we were able to print out the last line. Now, what if I want to count the number of days since 1946 that San Antonio has had a high in the hundreds, so triple-digit highs? How could I do that? Well, the first thing that I would have to do is, instead of having just lines, I would need to pare it all down to that. Remember, this is the average, high, and low. Now, how could we do this? I can make a val called highs. And what I want to do here is I want to take every single one of these lines, so lines, and I want to apply a function to it. And I want that function to pull out just that one temperature right there. So that would be a map. Now, the question is, how do I grab this? So I could use things like last index of to find the last comma and then to find the one before that and do various things with that. That is one option. I'm not going to do that option. And the reason I'm not is because there is another function that is very helpful to have. And to demonstrate this, let's pull up the REPL. Now, all of those lines are strings. And so the method that we are going to work with is a method called split, and split actually works on strings, and we haven't talked about it before because of what it returns. It returns an array of string. Well, prior to this chapter, we didn't know about arrays, so when we were first learning about strings, this would have been meaningless to you. Now you know about arrays, and hopefully you can look at this and tell what it does. This is a test. When I call split on space, it breaks this one string into multiple strings based upon where the spaces are. So the word this gets put into it. That spacing was for prints. It actually threw away the spaces when it gets to them. So what do I want to do here in order to pull out the right value? Well, I want to split on commas. So let's go ahead, and I'm going to use the long syntax, the rocket syntax, for building a function here. Actually, I guess I could do this in one line. No, let's not. Let's do val parts. The parts of the string is equal to L dot split on a comma. Okay, so that will give me back for each line an array that has all of these things inside of it. Okay. Now, this is going to be sub 0, sub 1, sub 2, sub 3, sub 4, sub 5, sub 6, sub 7. So the value that I want here is parts sub 7, but that's still a string because remember, split gives us back a bunch of strings. Even if the string happens to be a number, it's still in string format. So I can call 2 double on it. And then we can print line. And since the last high temperature was 78, we should get that. At least that's the theory. Let's see how this works. Oh, that's an error. What went wrong? Well, remember that little note in the download? What happens if we search for comma dot comma? I'll have to, I'm not going to bother explaining why that did what it did, but here we go. In 2006, there is a line that has no data for temperature, and notice that one of them is the high temperature. Okay, happens again in 2008. There are some of these, and that's it. Well, we ran into the problem where we got one of these dots here, and then we tried to call 2 double on it. That's a problem. We're not allowed to do that. So what I'm going to do in here is I want to only keep strings such that not the string contains comma dot comma. And let's see if that winds up being happier with us. Indeed it is, and it prints out the value 78, which if you recall is the high temperature from the last day. Now, I don't want the high temperature from the last day. I want instead to know how many days were above 100. And so the easiest way to do that is to print out I'm going to take highs. I could filter into a length, or I could use the count, that higher order function. Highs dot count anything where underscore is greater than or equal to 100. We save. We run. In San Antonio, since late 1946, there have been 733 days that have logged above 100. Raises the interesting question, what's the hottest day? How could we get that? Well, that is as simple as highs.max. And now if we run this, So there have been 733 days of triple-digit temperatures, with the highest recorded temperature in San Antonio being 111, up through 2011. So this gives you a nice little example. We used a recursive function to read data into an array. We used filter and map. I mentioned in the video on higher order methods that these were your most common ones that you're going to use. Filter to get rid of the lines that had a bad formatting for us where we had no data, and map to convert from this long line into just a single number, because all we were dealing with was the highs. And we also saw how we can use split to split a string into pieces based upon some delimiter. And in this case, this is a comma separated file, so our delimiter was the commas. So that's it for this video. You can feel free to download temperature data for wherever it is that you are, or where you're from, or just someplace that you find interesting in the US, and play with this. Download the data, find out whatever interesting questions that you might have. So, what are coldest days? How many days below freezing? Whatever it is that you find interesting, do that, and that way you can play with seeing how you can answer those things in Scala.